Hi, my name is Savannah, and with my teammates Marcus, Diana, Estelle, Yusuf, and David, we compose the Knee Augmentation Goal Team. The scope of our project is to design an assistive variable control load relief knee brace that supports joint function and the rehabilitation process by offering a pain cognizant, easily operable, and affordable device. This product would be beneficial to various patients who undergo knee surgery such as knee replacements, meniscus repairs, and ACL repairs. The project goals and objectives for designing a knee brace are multifaceted, aiming to enhance the user experience, promote effective pain relief, and facilitate the rehabilitation process post-surgery while seeking to optimize functionality, comfort, and overall effectiveness comparable to competitors. Ultimately, this device should improve the quality of life for individuals recovering from knee injuries or surgeries by getting patients back on their feet sooner to participate in normal daily activities.
A successful final design would greatly impact the overall physical health of the general public. Recovery time after knee surgery is, in most cases, a long, difficult, and painful process. The implementation of our brace can help ease the pain of the user while also building more strength in the joint during the process. This will allow for a better final recovery, reducing the risk of re-injury. The impacts of the project extend beyond individual users to encompass societal and healthcare realms. By developing an advanced knee brace, we aim to reduce reliance on invasive pain management methods, potentially decreasing healthcare costs and improving patient outcomes. Moreover, advancements in brace technology may spur innovation in related fields, driving progress in orthopedic care and rehabilitation. Ultimately, the project's broader impacts extend to promoting wellness, fostering innovation, and enhancing healthcare accessibility and effectiveness on a larger scale.
The brace design includes several innovative features to achieve the goals set earlier in our design process. The most important innovations being the motor to assist in load relief and electric stimulation to help activate the muscle around the joint. The electric stimulation was an idea presented to us by one of our stakeholders, Dr. Powell. Other innovations are the channels and pins used to adjust the length and the range of motion locks that adjust the angle that the brace is set to, as well as allowing free range of motion for later stages of the recovery process.
When starting the design process, the team first began by creating technology study memos outlining the user interface and how the brace should work. Fundamental anatomy about the knee joint, the different technologies that could be implemented into the brace, the materials that could be used, and the stakeholders involved in the design process.
After creating the memos, the team created our engineering design specification document. In the process of creating this document, functional and component decompositions were created. Pairwise comparisons were made to determine the biggest concern to acknowledge while designing the brace, as well as a house of quality. And finally, the customer needs were outlined and documented. The customer needs were generated by the team members and by the responses to a survey sent out to several people known by them.
After finalizing our engineering design specifications, the team moved into brainstorming to create full designs. This was done using a morphological chart that had various options to choose from in each functional subcategory. The main discrepancy was deciding which method of load relief would be the best, and the team decided that a system with high-speed electric motors and a gearbox would be best. After determining all the components that would be included in the final design, the team began creating CAD models and starting preliminary analysis on ANSYS. This was also done to help team members learn how to use ANSYS for future finite element analysis. During this time, a Gantt chart was also created to outline all prevalent dates for the project.
During the next phase of the design process, the team finalized the CAD drawings and the FEA and created a bill of materials, and from this bill, different order forms were created and placed. Manufacturing for parts that needed to be machined was outsourced to Diana's work, as they were kind enough to be willing to help with the creation of a lot of our structural parts. Some of our parts have yet to be machined or printed from the company, which is why the prototype shown in this video has parts that differ from the rest, and certain tests have been unable to be completed. While the delay in manufacturing is affecting the quality of content in this video, it will not affect the quality of our final product. Testing procedures play a critical role in ensuring the effectiveness, safety, and user satisfaction of the knee brace design. One completed test was testing the EMG sensors and controls timing. This was done by mounting the motor and placing a camera in front of it to record. A signal was then sent from the controls to the motor, and the footage from the camera is used to determine the responsiveness and accuracy of the brace's sensors and controls. This ensures that inputs from sensors are detected promptly and controls function reliably. By evaluating timing performance, we can verify the real-time functionality essential for user interaction and safety.
Another testing procedure was the testing of the range of motion mechanism and the security of the brace straps. This was done by attaching the brace to the user and recording them walking around as shown in the accompanying video.
In this video, you will see functional testing of the consolidated planetary gearbox and motor. Weighing only approximately 1 pound 1 ounce, execution of the experimental controls demonstrates backdriving capability, making the progress promising for continued brace integration.
Stop it and take it back the other direction.
This next video demonstrates the functionality of the EMG sensor that detects the pulses of the user's leg.
So here I have it flatlining, and then you can flex your muscles and you can hold it at high, and then you can relax them and it falls back to low, and you can do it cyclically as well. You can use this to mimic the steps. Yeah.
Although our design isn't 100% complete in this video due to manufacturing constraints, our team believes we have created an innovative product that can truly help people. Whether we get chosen to participate in the in-person showcase or not, we appreciate the time that was spent reviewing our video. Thank you and have a great day.